Hello and welcome to the Daily Space for today, Friday, December 4th, 2020. I am your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put science in your brains. Um, eh, Today, we have news of a torrential downpour of data from the Gaia mission. This amazing mission has just posted an early version of its Data Release 3 catalog. The finalized version will come out in spring 2022, but this interim release has enough content to keep everyone busy until then. The release contains, I kid you not, 1.8 billion stellar positions, 1.5 billion stellar colors, 1.5 billion stellar parallax, and proper motion measurements. Those are not necessarily of the same 1.5 billion stars between the colors and the parallax, and 1.6 million extragalactic sources. This kind of data allows us to answer precisely questions about where we are, what is around us, and where all of it is going over time. Over the next few weeks, we expect to see a deluge of papers. One of my favorite phenomena with Gaia data is the automated paper. There are folks out there who know that specific questions can be answered with the data, and they have their software ready to mine the data, find the results, and essentially plug the results into a pre written paper using software that has, if this value, then use this paragraph already written. It's already coded. They can go to sleep with the data plugging and wake up to a completed paper. Already, this cool science is being written. I don't know if these results came from that kind of an automated system, but this data precisely measures our solar system's motion in relation to distant quasars. And using this data, researchers could calculate the acceleration of our solar system as it experiences gravity from the center of our galaxy. This is the F equals ma acceleration that determines our solar system's orbit. The number is small, just 2/100 billionths parts of the gravitational acceleration caused by the Earth on its surface. But it is the kind of data that allows other research to be done. Stay tuned. The data has arrived and the science will follow.
It's not often I get to bring you right back to Earth for some local planetary science, but I get to do that today. We don't just study volcanoes in space, y'all. In Alaska, there is a group of 6 stratovolcanoes on the ironically named Islands of the Four Mountains. These volcanoes are steep sided and tall, like most stratovolcanoes. And now it seems they may be connected and part of one large underground caldera. As opposed to a mountain, a caldera volcano is a huge pool of magma that can cause the biggest, most destructive eruptions. The most famous is Yellowstone, also here in the United States. Per the press release, unlike stratovolcanoes, which tend to tap small to modestly sized reservoirs of magma, a caldera is created by tapping a huge reservoir in the Earth's crust. When the reservoir's pressure exceeds the strength of the crust, gigantic amounts of lava and ash are released in a catastrophic episode of eruption. The islands of the Four Mountains are in the Aleutian Island arc that reaches from the coast of Alaska out into the Pacific Ocean. It's formed like most island arcs on Earth, where one plate subducts or sinks under another. In this case, the plate is subducting under the North American plate, giving rise to a long curved chain of volcanoes. The press release goes on to explain caldera forming eruptions are the most explosive volcanic eruptions on Earth, and they often have had global effects. The ash and gas they put into the atmosphere can affect Earth's climate and trigger social upheaval. For example, the eruption of nearby Okmok volcano in the year BCE 43 has been recently implicated in the disruption of the Roman Republic. The proposed caldera underlying the islands of the Four Mountains would be even larger than Okmok. Now, this theory is by no means certain, and the scientists involved want to go to the islands and take more direct samples of the rocks to match chemical compositions, as well as collect seismic data. This research was done using bathymetry only, depth soundings collected last century. The results will be presented on Monday at the American Geophysical Union's fall meeting, and I, for one, am very interested in how this turns out.
I have to admit, I am totally a volcano stan, and I love that story, and I'm going to go do so much more reading on it. But we have more science. From the changing Earth, we now look to the changing sky. One of the not often discussed justifications for building the Hubble Space Telescope was its ability to resolve the structures of planetary nebulae. These often geometric structures surround dead and dying stars and are formed when these stars puff off their outer layers of atmosphere. Most of the planetary nebula we study are fairly old and unchanging as they glow faintly around a white dwarf in their core. But most is not all. There is one notable exception, the Stingray Nebula, or more officially, Hen 3 1357. In 1996, the central star underwent what is now thought to have been a short lived helium flash as it changed evolutionary stages. And with that flash, it created a dramatic looking planetary nebula. When re examined in 2016, Hubble found the system dramatically fainter and structurally changed. Where the shells of gas in the nebula are often seen to expand away from their origin, in this case, the inner shells were seen to fall back towards the center. According to research team member Martin Guerrero, this is very, very dramatic and very weird. What we're witnessing is a nebula's evolution in real time. In a span of years, we see variations in the nebula. We have not seen that before with the clarity we get with this view. This work is detailed in a new paper in the Astrophysical Journal with first author Bruce Ballack, who points out in most studies the nebula usually get bigger. Here it's fundamentally changing its shape and getting fainter, and doing so on an unprecedented timescale. Moreover, to our surprise, it's not growing any larger. Indeed, the once bright inner elliptical ring seems to be shrinking as it fades. This set of observations has captured a short lived phenomena driven by changes in the central star. Last night, Hubble put out a tweet that is one of my favorite of the how it started, where it went meme, where it listed the image on the left, that 1996 image, as how it started, and the 2016 on the right as how it went. So, this is amazing because Hubble caught the earliest moments of a planetary nebula. And now, for generations, humanity will get to watch as the star dies and the nebula is born.
Planetary nebula versus nebula. Astronomers cannot be trusted to name things, including what happened in this story. Back on November 13th, we brought you a story that researchers using the Pan-STARRS Survey Telescope had discovered a new object known as 2020 SO, and then that it might be a long lost Centaur rocket booster from the 1960s and not an asteroid. Well, scientists have now confirmed that this object is indeed that rocket booster. A team from the Lunar and Planetary Laboratory at the University of Arizona used NASA's Infrared Telescope facility to get spectrum data of 2020 SO to compare to 301 stainless steel, which is what the Centaur rocket boosters were made of. At first, the data were not a perfect match, and the discrepancy was thought to be due to the effects of space weather on the booster. So the team set out to observe another Centaur rocket booster known to be in orbit around Earth. However, that's not as easy as it first sounds. As team lead Vishnu Reddy said, because of the extreme speed at which Earth orbiting Centaur boosters travel across the sky, we knew it would be extremely difficult to lock on with the IRTF long enough to get a solid and reliable data set. The team pulled off what seemed to be impossible on December 1st, gathering spectrum data on a 1971 Centaur booster. A new comparison to the 2020 SO spectra was performed, and they were a definitive match. Now, 2020 SO will not stay in orbit around Earth for very long. It's expected to escape back out into a new solar orbit next March. Still, as Reddy also pointed out, this conclusion was the result of a tremendous team effort. We were finally able to solve this mystery because of the great work of Panstars, Paul Kotis, and the team at CNOS, LBT, IRTF, and the observations around the world. So, congrats to all involved. It's nice to see something work this year. Finally, we have one quick announcement. Our co host, Annie Wilson, recently started a CosmoQuest Book Club over on Goodreads. She and I have picked our inaugural selection for December, and it is Packing for Mars: The Curious Science of Life in the Void by Mary Roach. The cover blurb reads: the best selling author of Stiff and Bonk explores the irresistibly strange universe of space travel and life without gravity. From the space shuttle training toilet to a crash test of NASA's new space capsule, Mary Roach takes us on the surreally entertaining trip into the science of life in space and space on Earth. Yep, space toilet training. And now you know why Annie wants to read it first. We plan to review the book during Daily Space at the beginning of January, and we'll have discussions over on Discord. Make sure to join both if you want to read along and chat. This has been the Daily Space.
And I just have to add, Mary Roach is like one of my favorite authors. You want to read this book, people. You want to read this book. But the calendar actually requires me to say something entirely different. It's December. There are less than 30 days left in the 2000 year that shall not be named tax year. And we're part of a nonprofit, the Planetary Science Institute, a 501c3 nonprofit. And if you need a tax deduction, we will gladly take your donations. If you're doing okay enough financially that you're worried, will my write-offs be great enough this year? We are happy to help. We're here thanks to the generous contributions of so many of you. Because so many of you that are financially able have taken the time out to give, I'm able to pay Annie, Allie, Beth, Aviva, and Rich for the work they do keeping everything around here going. You can either donate to us directly through Kindful, or you can become a patron at patreon.com/CosmoQuestX and sustain us throughout the year with your giving. If you are doing okay and you would like to see us do more here at CosmoQuest, please consider supporting us and get that tax write-off that you hopefully need. Anyways, you can learn about all of this at cosmoquest.org. We would like to add 60 new patrons to our Patreon community by the end of the year. Will you be one? I hate doing this. I hate asking for money, but this is how we do what we do, people. Give and I will stop begging. Okay, for real this time. This has been The Daily Space.